All right, so today in Algebra 2, we're going to finish up section 6.2. We're going to today focus on the graphing calculator or Desmos. Okay, so remember that you can always use Desmos if you are at home and don't have a graphing calculator. So we're going to talk about using regression to find an exponential model. So number one, it says Joseph is making soup. The soup reaches the boiling point and then, as shown by the data, begins to cool off. Joseph wants to serve the soup when it is about 80 degrees Fahrenheit or about 10 degrees above room temperature, 68 degrees Fahrenheit. Explain why the temperature might follow an exponential decay curve as it approaches room temperature. Look at the scatter plot. Okay, so this is where we're going to, on a graphing calculator or on Desmos, type in these times in these temperatures. So on a graphing calculator, we would do L1 and L2. So we would go to our stats list and edit. On Desmos, you can insert a table. And so L1, L2 on a graphing calculator. So L1, we're going to do our time at 2. The next time they give me is our first time is 0 minutes. The next time is 2, 3.5 minutes. So we would put 3.5, 5, 7.5, 10, 15, and 20. And then the temperatures that go along with that. So 212, 185, 170, 162, 145, 138, 125, and 117. So again, that's just everything from this table over here, the picture that is shown to you. Okay? All right, so then we would graph this, again, either Desmos or graphic calculator, and we would, on a graphic calculator, okay, hopefully we're in class and I'm showing you this, we would have to do stat plots, and you would see where you get something that looks, you'd have these dots that look something like this. Okay. You'll want to make sure to have an appropriate window. So our window, our x min, we would put at 0. Our x max, so we see that the time, the maximum that we're going up to is 20, so we could do a maximum of about 30. Our y min, again, I would do 0. Our y max, the highest temperature that we have is 212, and so I would do like 220 with a scale on the y of, let's say, 20. That way we would be able to see everything. So explain why the temperature might follow an exponential decay curve as it approaches room temperature. We could tell that without having to look at a scatter plot, without having to graph it. We see as the time increases, the temperature is decreasing. Okay, so the rate, we could say the rate of cooling appears to slow as it approaches room temperature. And again, this is where we would look at our graph to confirm that. Therefore, because it's slowing, right, we know that it's going down, it's decreasing. This indicates exponential decay. And here are asymptotes. So with an asymptote at y equals 68, because that is our room temperature, and we're not going to let it go below that. Of course, the soup could go below room temperature, right? But we're not going to let it get below room temperature because we're not talking about putting it in the refrigerator or anything. All right, so then it says B, find an exponential model for the data. Use your model to determine when Joseph should serve the soup. So again, first we would enter the data as a list in our graphing calculator. Then we would use the calculator to find an exponential regression equation. So on the calculator, again, we would do that stat and then we would hit calc, and then an exponential regression is where we would go down on the calculator button. And when we do that, it tells me that I have an A equal to 192.26, and I have a B equal to 0.9722. I know that my exponential equation looks like y equals a times b to the x power. So I would plug those in. So y equals 192.26 times 0.9722 to the x power. So that's going to give us that exponential equation, that model. And then it asked, when should he serve the soup? So we could now put this equation into the graphing calculator underneath the y equals, so that we can see what it looked like graphed. But the easiest way then to look at this would be to go to the table, because it says what was the approximate temperature 35 minutes after cooling started. So we could go to our table of values and look to see when is my temperature, when is my y value of 35, or you could trace on the graph when is the y value 35. On Desmos, again, you could trace and see when is the y value 35, or I could just plug it into the equation, y equals 192.26 times 0.9722 to the 35th. If I plug it in, that tells me that's approximately 71.67 degrees. Again, or I can look at that table. Okay. Let's see. The original question asked, Joseph wants to serve the soup when it's about 80 degrees Fahrenheit or about 10 degrees above room temperature. So when should he serve it? So we can look to see, okay, when is it 80 degrees? So again, back on our graph, look to see, so we can look at graph for y equals 80, and we see that our time when y is 80, our x is approximately 31 minutes. So Joseph should serve the soup at approximately 31 minutes after it began to cool. Then it would be at a temperature of 80 degrees. This is a very hard lesson to just do a video on in Smart Notebook without a graphing calculator or Desmos there for you. So again, we would be doing the majority of this in class, and your homework would be done in class so that you would have that graphing calculator to get the assignment done.